Welcome to the DIY Honda Garage channel. This presentation addresses the diagnostic trouble code DTC P2126, which indicates that the APP, Accelerator Pedal Position Sensor B, also referred to as TP, Throttle Position Sensor E, has been detected as out of range. The APP sensor is crucial for controlling engine performance and throttle response, as it informs the Powertrain Control Module, PCM, about the current position of the accelerator pedal. Specifically in the Honda CRV 2017 to 2022 model, the APP sensor can be found connected to the accelerator pedal assembly. It includes multiple signal outputs that convey the pedal's position to adjust engine power accordingly. A malfunction in the APP sensor can lead to undesired driving behavior, including stalling or unintended acceleration. This presentation will provide a step-by-step guide on diagnosing and troubleshooting this error effectively. DTC P2126 indicates an issue with APP sensor B, which monitors the accelerator pedal's position and communicates this information to the PCM. The APP sensor ensures that the engine responds accurately to the driver's throttle input. Located at the accelerator pedal assembly, it plays a critical role in determining vehicle acceleration and engine performance. When this sensor is out of range, it may not provide the required voltage signals, potentially leading to problems such as poor acceleration response, failing to accelerate, or unexpected engine behavior. The sensor operates by sending voltage signals that correspond to the pedal position. If these values are outside specified thresholds, it generates the DTC. Understanding the location and role of the APP sensor is essential for effective troubleshooting. Several factors may lead to DTC P2126 being triggered. Firstly, poor electrical connections at the APP sensor or the PCM can cause intermittent signals, resulting in voltage readings out of the specified range. Secondly, the APP sensor itself may be malfunctioning due to internal faults, leading to improper signal output. Lastly, there could be potential issues within the PCM, which interprets the sensor data and controls the engine accordingly. Other possible causes may include damaged wiring or open circuits in the signal path between the sensor and the PCM. Each of these factors can contribute to erratic engine behavior and must be thoroughly checked during the diagnostic process. When DTC P2126 is triggered, various symptoms may alert the driver to the underlying issue. A common symptom is poor throttle response, which is characterized by a delay in acceleration when pressing the pedal. This can lead to stalling or hesitation during driving, making it feel as though the engine is not responding effectively to the driver's inputs. Additionally, the check engine light is likely to be illuminated on the dashboard, signaling that there is a fault with the vehicle's electronic systems. If left unaddressed, these symptoms can lead to further complications, including reduced fuel efficiency and unpredictable driving dynamics, making it crucial to perform timely diagnostics. The first step in troubleshooting DTC P2126 involves verifying the current conditions of the vehicle. Begin by turning the vehicle's ignition to the on mode without starting the engine. Using the HDS, Honda Diagnostic System, check the voltage values for APP sensor B against the specified thresholds. If APP sensor B's voltage is less than 0.19 volts, the failure has been duplicated and you should proceed to step 3. If the voltage is within acceptable limits, move to step 2 to investigate further. This verification step is crucial to confirm that the issue is persistent and to gather data for further diagnostics. In the second step of troubleshooting DTC P2126, recheck the APP sensor B voltage while still using the HDS. If the voltage readings exceed 2.62 volts, this confirms a failure. and you should move on to Step 8 for additional diagnostics. However, if the readings are not matching these thresholds, consider the possibility of an intermittent failure. At this point, inspect the electrical connections to the APP sensor and the PCM for any signs of loose terminals or corrosion. If there is an onboard snapshot of the DTC, attempt to recreate the conditions under which it was recorded. This can help identify triggers or contributing factors associated with the malfunction. The third troubleshooting step for DTC P2126 requires turning the vehicle to the off mode and disconnecting the 6P connector from the APP sensor. Next, switch the ignition back to the on mode again while keeping the APP sensor disconnected. Use a multimeter to measure the voltage between the specified test points on the connector. The expected voltage between the two test points should be approximately 5.0 volts. If you find that the measured voltage is around 5.0 volts, proceed to Step 4 to check for shorted wires. If not, further investigation is needed to check the integrity of the wiring and connections to both the sensor and the PCM. For the fourth step of troubleshooting DTC P2126, the process begins by turning the ignition off and utilizing the HDS to jump the SCS, service check switch line. After waiting for more than 1 minute, disconnect the PCM connector A, which has 50 pins. With both the APP sensor and PCM connectors disconnected, check for continuity between the designated test points. The expectation here is that continuity should be present. If so, this indicates that there is a short in the APS2 wire between the PCM and the APP sensor. If continuity is not present, you may continue on to Step 5, which checks for open wires. In troubleshooting Step 5 for DTC P2126, you'll use a jumper wire to connect terminals A and B of the APP sensor connector to check for continuity in the APS2 wire. Ensure that the vehicle is powered off and the APP sensor is disconnected when you perform this test. After creating the jumper connection, it will be important to measure continuity between the specified test points on the PCM connector and body ground. If continuity is confirmed, this indicates the APS2 wire is functioning correctly, and you can advance to Step 6 to check the PCM's internal circuits. If continuity is not found, an open circuit exists in the wire, requiring repair between the PCM and the APP sensor. The sixth step in troubleshooting DTC P2126 involves conducting a check of the PCM internal circuit. Begin by removing any jumper wire you previously placed and ensure that the PCM connector A is securely reconnected. By using another jumper wire, connect terminals A and B of the APP sensor connector while exiting the SCS mode with the HDS. Turn the vehicle back to the on position and measure APP sensor B values again using the diagnostic tool. The anticipated voltage is supposed to be under 0.19 volts. If this condition is met, further investigation through authorized service information can provide insights or consider substituting with a known good PCM. Conversely, if the voltage does not match the threshold, replacing the accelerator pedal module may be necessary. For troubleshooting Step 7, the aim is to investigate the VCC5 5-volt reference line for continuity issues. As before, turn the vehicle to the off mode and utilize the HDS to jump the SCS line while waiting more than 1 minute. Disconnect the PCM connector A. Then, follow the same continuity check method from previous steps. Connect terminals A and B using a jumper wire to ground, measuring the circuit between the 5-volt reference line of the PCM and body ground. If continuity is confirmed, it indicates the VCC5 wire is intact, and further diagnostics or PCM replacement may be warranted. If not, repair any open circuits found within the VCC5 wire to restore proper functionality to the APP sensor and PCM. The 8th troubleshooting step addresses the APP sensor directly. Begin by confirming the vehicle is in the off position before disconnecting the APP sensor 6P connector. Turn the vehicle ignition back to the on position. Measure the voltage present at the specified test points of the APP sensor connector. A proper voltage output should measure around 5.0 volts. If this condition is met, the next logical step is to replace the accelerator pedal module as it signifies an internal fault within the APP sensor unit. If the voltage is incorrect, it suggests other potential concerns which can be further diagnosed in subsequent steps or by using external reference materials. The final troubleshooting step in diagnosing DTC P2126 focuses on the SG5 line. With the vehicle turned off, jump the SCS line using the HDS again and wait over 1 minute. Disconnect the PCM connector A. Then utilize a jumper wire to connect the SG5 line from the APP sensor connector to body ground. Once established, check for continuity between the relevant test points on the PCM connector and body ground. If continuity is confirmed, it indicates that the SG5 wire is functioning as intended, allowing you to inspect authorized service information or consider substituting a known good PCM. If continuity fails, repair any open circuits that may exist between the SG5 wire at the PCM and the APP sensor, ensuring a complete inspection and repair of the signal pathways. After completing the necessary repairs for DTC P2126, it's essential to perform a final repair verification. Begin by rechecking the APP sensor values using the HDS to ensure they are now within the correct thresholds. Any adjustments or replacements made should be validated to confirm that the issue has been resolved. Take the vehicle for a test drive as well to assess the effectiveness of the repair. You should verify that the throttle response behaves normally throughout various driving conditions. Observing whether the check engine light remains off after driving will also indicate that the problem is resolved. This verification step is critical to ensure that the vehicle operates safely and effectively. To prevent the recurrence of DTC P2126 in the future, it is advisable to implement a regular maintenance routine. Begin by inspecting the wiring and connectors related to the APP sensor and PCM for signs of wear or damage. Environmental factors such as moisture, dirt, and corrosion can significantly impact electrical connections. Therefore, routine checks can identify problems before they lead to serious faults. Additionally, keep the vehicle's software updated, as manufacturers may release updates to the PCM that enhance performance or resolve known issues. It is also advisable to follow the manufacturer's service intervals and recommend service practices to prevent faults related to critical electronic components like the APP sensor. In conclusion, understanding the role of the APP sensor is crucial for successfully diagnosing DTC P2126. Following a systematic troubleshooting approach allows for pinpointing the exact failure area, whether it be the sensor itself, wiring, or the PCM. Each step not only aids in identifying issues, but also ensures that repairs are executed correctly. Post-repair verification is essential to confirm functionality before returning the vehicle to service. Implementing preventative maintenance practices will help mitigate future occurrences of this DTC. By maintaining diligence in diagnosing and repairing DTC P2126, drivers can ensure their Honda CRV operates effectively and safely. Please like and subscribe to the channel. See you next time.